So you're live now, you can start.
Okay, okay, thank you. Hello, students. Good afternoon. I hope you are enjoying the online course on nuclear and radiochemistry. And through this live session, the intention is to clarify any doubts that you have about the course and about anything that you could not understand. So you can write in your chat box, and I'll try to answer those things in the chat box, or maybe by the by my link. I can try to explain in case there are some things which I immediately not able to tell you. I can write in email also separately. So go ahead, and if you have any questions, do write in the chat box. Yes. See something else. 91996. Hello. Yeah, there is one question. Uh, Sriram, what are the things we will learn about this course? So this is the course on nuclear and radiochemistry. I'm sure you are attending the class like this online lectures. So basically, this is the nuclear and radiochemistry. Nuclear chemistry deals with understanding the property of nuclei using the chemical means. And radiochemistry means you are studying the chemistry of different elements using radioactivity as a tool. So you understand the structure of nucleus, decay of nuclei, you understand how to detect these radiations, alpha, beta, gamma, and other radiations. So it's all about the phenomena that occur when nuclei decay. It's also about detecting those radiations that emitted from radioactive atoms. It's about interaction between different nuclei, the nuclear reactions. And later on, as you will see in the later part of the course, there will be applications of different aspects of nuclear and radiochemistry in different areas. Okay, question from B. Kartika. How will be the exam pattern for this course? So right now there are assignments for every week. So you will have 12 assignments for 12 weeks, and most of them are multiple choice questions. Then sometimes in April you will have a examination which will be descriptive. So it will be physically you have to go to a examination center and write the exam, and the answer sheets will be evaluated manually. I hope it clarifies your question. Yes, there is a question from Armugam Raman. Okay. I can move nuclear medicine technician. I'm afraid not. For nuclear medicine technician, there are the specific courses that requires a certification course, and so this course may not be adequate for that kind of a work. Mani is asking, is there any summer internship on nuclear chemistry on any university, sir? So summer internship, you can in fact apply for internship if you are doing your MSc. You can apply for internship at BARC. You can write to Head Human Resource Development Division and a letter from your HOD to the Head HRDD BARC stating that you are in this semester, and then you can recommend you for this internship. So BARC internships are taken care. what job opportunity for this course are Mugam? Okay, so this is a, it is like, it's a postgraduate, this is meant for the postgraduate. And if you are going to be in a job where you require the knowledge of nuclear science and technology, for a nuclear science subject, there are many vocational courses going on. Like there is a DIP RP course, postgraduate diploma in radiological and hospital physics. The people who operate this PET CT SPECT machines for cancer diagnosis, and also teletherapy machines, or even in industrial radiography. So this course will definitely enrich you in terms of the fundamental knowledge that is required for that course. So from vocational point of view, you have to go for other course, but this becomes a fundamental background. This forms the background for such courses. Well, there is another question from Karthik. If the exam is descriptive, is it going to be written on computer based? Will there be multiple choice questions? No, it is descriptive. So you have, as I understand, you have to go to an examination hall and write in the answer sheets. So then only that you submit your answer sheets, which will be evaluated by us. So it will not be writing on a computer. Okay. Armugam says, I have completed BSc Medical Radiology and also have experience PET-CT technician. Good, that's very good. So this course essentially gives you the fundamental knowledge in that area, like for example, detection of radiation. So when you attend the lectures on radiation detection, you will get much more information from attending this course than what you get into during that medical radiology course. So the more basics, you learn to know more of the basics of what is required for applying these radiations and radiation technology for societal applications. So any area you take, whether you are applying the radioisotopes for healthcare or industry or agriculture or food technology, the basic, like for example, the field for the radiation. What is the radiation field when you are using a survey meter? You immediately come to know that survey. See, once you have understood this course, then there is survey meters use ionization chambers. Different counters use different scintillation detectors or GM counters or this HPG detector. So you understand the basic mechanism how a particular instrument is functioning, or like radiation, when it is radiation like mutations in agriculture, you understand how the agriculture applications depend upon the effect of radiation on different materials. That's the purpose of this course. Similarly, for example, for the PET, you are using F18 for the PET FDG, no? F18 FDG. So how fluorine 18 is produced in a cyclotron? What is the energy of the projectile, that is proton? What is the target? And so you will have the basic knowledge of the nuclear reaction that will be used for producing a particular PET isotopes. Like gallium-68. Gallium-68 is coming from germanium-68. Germanium-68 is produced by a nuclear reaction. So you will get the fundamental knowledge about producing different PET isotopes. Yes, you can write RSO2 exam. If you have, you can, for RSO course, then I think there is a course by our BARC RPAD. So RSO course, that is a 21 days course. So this course will be much more advanced compared to what you will learn in that course. So this once you have passed this course, that you will find very easy to complete that RS2 exam. Okay, Devyani Ganorkar, how can this course help a chemistry student? This is for the chemistry students only. Like for example, if you are handling radioisotopes in a laboratory, you are doing separation of radioisotopes using chemistry. You do solvent extraction, ion exchange, extraction chromatography using radioisotopes. So you will understand the basics of that course, basics of that techniques using this course. Or you are detecting a radioisotope in a detector. This will help you know how to count the samples or how to interpret your data. So all this is for chemistry only. Though in the beginning you will find there is more of physics, but you essentially in the core of this is the chemistry. How Madame Curie discovered those elements like radium and polonium in 1898 by using chemistry. So chemistry of radioactive elements. So how to handle radioactive elements, so that is taught in this course. So it's all about chemistry. But then see, there are very thin boundaries between different subjects. Like when somebody is telling about he's working on PET-CT, so that is healthcare, nuclear medicine. So the research is now has no fixed boundaries like chemistry, physics, or life sciences, or healthcare. So there is a interdisciplinary work in any field. When you take up a career also, you will have to learn about a little bit of physics, chemistry, even life sciences also. So it is meant for chemistry students, but then when you are going for a job, you may not be doing chemistry alone. You may be handling different types of equipments. You may be handling different types of facilities. So this will help you prepare for those courses. Okay. So she is an analytical chemistry graduate. Very good. In this radio pharmacy, radiopharmaceuticals. You are working in a pharmaceutical laboratory, and which they use radioisotopes. It's like you will get to know more about this radioisotope applications in the later part of this course. There are techniques called radioimmunoassay. For example, the thyroid hormones T3, T4, TSH determination, you can use radioisotopes of iodine to determine their concentrations at the nanomolar scale. So that is all chemistry, but you use the radio tracers, radioisotopes as tracers to determine the concentrations of the different antigens like T3, T4, TSH in the body. And so when you are doing separation, this RIA, the radioimmunoassay is called sub-stoichiometric isotope dilution technique. So you use the different antibodies, labeled antibodies, and interact with the antigens like T3, T4, TSH, and then later on determine the concentration of these hormones at very, very low concentrations. So in analytical chemistry also you will have, even in solvent extraction, ion exchange separations, people are using radio tracers as to track the reaction. So for example, you want to find out the distribution coefficient of an element between the two immiscible liquids, you can use radio tracers. So many, many applications in chemistry, which will be clear in the second part of my lectures. Okay, another question from Armugam. Before I operate PET CT scan, only after successful that course, I can operate radiopharmacy like FAT, 99M technetium, iodine therapy, drugs with nuclear medicine, physician supports. Yes. So there are diploma in nuclear medicine. This is also a DMRIT. DMRIT is a course offered by DARC, even Tata Memorial and Radiation Medicine Center in Mumbai. They offer these courses where you handle the radioisotopes used in nuclear medicine. Sriram, I am a BCSE student. I understand by CSE you mean computer science engineering. Please clarify this part. I am not very clear whether CSE stands for computer science. What are benefits of learning this course? So I'm afraid if it is computer science, then this may not be of much use. But as a general science, see, we study, normally the students will study in chemistry or physics about different topics. Like a chemist will study analytical chemistry, organic chemistry, physical chemistry. But in physical chemistry, there is a small part called nuclear chemistry or radiochemistry. And the subject is as old as more than 125 years because the radioactivity was discovered in 1896. So there is radioactivity everywhere. Yeah, computer science. So in computer science, if you are going to suppose a computer scientist may be also working on computers which are interpreting the computer tomography. No, this what we call as the PET, the positron emission tomography, or there is a for industrial radiography also the tomography is used to determine the 3D structure of the machine parts. No, they use computer algorithms to do the, suppose there are any defects inside a particular specimen, and then you do tomography, 3D structure of a particular specimen. So there, the radiation is used in determining the internal structure. Suppose there are minor cracks inside a material. From outside you don't see, but you expose this to gamma radiations and you do tomography. So there you have a source and you have a detector, and you determine the different slices of this specimen. You get the 3D image of that particular specimen. So there, what you require is the computer engineers to interpret that data. So definitely, when you have the later part of my course, will have different applications of radioisotopes and radiation technology, and one of them being the computer tomography for industrial objects. So definitely, there you will be able to appreciate the applications of this course. Okay, so Armugam is outside India and he says, can I write proctored exam? This part I don't know. You have to find out from the organizers, that the IIT Bombay, maybe the host institute, IIT Bombay, they will be able to explain. So you put your questions in this chat box and they can respond to this later on. I'm sure Devendra and Omkar are seeing this chat box and they can reply to you whether you can write from there. Okay. Bhanupriya Balakrishnan is asking a question. Why in proportional counter using gas, not air? Yeah. So the proportional counter, the primary ion pairs that are produced, they are multiplied almost by million times. And so, if you use the air contains oxygen also. And oxygen, about 21% oxygen in air. So oxygen has got a very high electron attachment coefficient. That means when the ionization takes place, that electron can be attached by the oxygen molecule, so that ionization process is lost. So you require a gas which does not have any electron attachment coefficient. It should not attach with the electrons. and so you require inert gas. So inert gas you take helium, argon, neon, that type. And argon is chosen because of the ionization potential of argon, about 26 electron volt. And then you mix with some amount of methane, that is to take care of the spurious pulses. So certainly air cannot be used as a fill gas in proportional count. But in ionization chambers, which are used in survey meters, which are in current mode, you don't require to count each pulse. So you can use air as a fill gas, where you just want to know level of radiation. But in proportional counter, you are counting each event, each pulse. So the pulse, the event should not be lost. And that is why we use a pure gas, where the multiplication factor has to be constant. That is possible if there is no any component which will capture electrons, which is undesirable. Chlorine, fluorine, oxygen, electronegative gases are not required. Okay, Armugam is asking, this course eligible for RSO exam or additional two course? Yeah, this is not eligible. You will have to attend that course organized by BARC for RSO or maybe AARB. So this will only help you in understanding those things, but it is not a part of that RSO 2 course. There is a strict syllabus for RSO 2. And this is a course for actually postgraduate students who are pursuing their PhD and maybe get MSc. So there is a national education policy of a flexible basket of elective courses, and any student interested in this subject can choose this course to fulfill the credit requirements for his postgraduate course, PhD or other courses. So it is from that point of view, not for a specific vocational course like RSO2 or RD level. Internship is given to course toppers. Okay, that's a good information from Bharti. Thank you, Bharti ji. Yes. When temperature and pressure changes in ion chamber, percentage of uncertainty will be. So these ionization chambers are, as I mentioned, no, they are for gross accounting of radioactivity radiations. So see that this is the number of ion pairs that are formed inside the chamber. That is not going to depend upon the temperature and pressure. It's a sealed container and the number of molecules of the gas are fixed there. So radiation is going inside the chamber, ionizing the gas molecules, and you are collecting the ion pairs across the electrodes, cathode and anode. So it will not depend upon the change in the pressure and temperature. Okay, so Aniket has a question. Is this course beneficial for radiopharmaceutical research? Very much beneficial. In the second part of my course, you will find the lectures on radioisotope applications in healthcare. So there you will understand how this course is beneficial for radiopharmaceutical research. So you will get this information later on. So there is a question, could you please elucidate on Moss power spectroscopy? So the Moss power spectroscopy is, though I have not covered so far, later on I'll be covering some techniques like hyperfine interactions. The Moss spectroscopy also is of that type of technique, but that will be at the end of this 40 by first 40 hours, no? Somewhere around lecture number 38, 37, 38, you will get about this hyperfine interaction. Not exactly Moss spectroscopy, but similar to that, there are other techniques. Basically, in Moss power spectroscopy, you are having the quadrupole moment of the nucleus is interacting with the surrounding electric field gradient, and by the recoilless absorption, you are seeing the absorption of the gamma ray by the levels of the daughter nucleus, like cobalt 57 and iron 57. So that gives you information about the structure, the chemical structure around the iron molecule atoms. So that is a nuclear probe technique, and nuclear probe techniques I will discuss somewhere around lecture number 37, 38. Any other questions by the students? Okay, Aniket, I am a student of MSc Nuclear Medicine student, and further want to join PhD in the field of radiopharmaceuticals for diagnosis and therapy. Well, excellent, very good. Yeah, see, you know this. There is a university called Homi Bhabha National Institute in Mumbai. It is in the BARC campus. And there you have a program on PhD in chemistry where the healthcare, the pharmaceutical is also done. You can register there for PhD, or the Tata Memorial Center also invites applications for PhD. So you can join the students, these institutes for your PhD program. There is a all India level written test or interview. So you can certainly try to enter these institutes for your PhD. What you consider while disposal of technetium 99M generator, 10 half life, consider activity of parents or activity of daughter, or equilibrium of parent and daughter need to be taken. Yeah. So that is a very good question. Technetium 99M has a half-life of 6 hours, and this technetium 99M by internal transition decays to technetium 99G, the ground state, having half-life of 10 power 5 years. So in radioactive waste disposal, there are different philosophies. One is the dilute, decay and dispose. So if the radioactivity decays, so by 10 half-lives, activity decreases by a factor of 1000. So you can for technetium 6 hours, you can wait for 1 year and it will become almost negligible. Other one is you can concentrate and contain. So like cementation, for this, which are long-lived, you can concentrate and cementize them. So technetium 99M is not a problem. You can store it for a long time and then dispose it, because the 99G, then for 5 years half-life, activity in terms of activity will be very, very small. So there is natural radioactivity around us in the form of carbon 14, potassium 40, and if the activity of this technetium 99 ground state becomes of the order of natural radioactivity, then it can be disposed of. That is the philosophy. Could you please share your email address in case I have any doubts? I have given my email ID in my each lecture, and you can write down B.S.Tomar1957@gmail.com. So feel free to write to me if you have any queries. Okay, there is a question from Lakshya. What is the meaning of a prompt neutron? So when a reaction takes place, the neutron is produced, let us say, in a reaction. That neutron is coming from a hot nucleus. The nuclear reaction is not yet completed. So this nucleus is produced in a nuclear reaction. Neutron is produced in a nuclear reaction. That is the time scale of that reaction is very, very short. So that is 10 power minus 17 second or minus 15 second. That is called as a prompt neutron. And when the neutron is produced after a beta decay, that is called as a delayed neutron. Like some fission products, when they decay, undergo beta minus decay, and after that the neutron is emitted from the excited state of the nucleus. That is called a delayed neutron. But the excited nucleus immediately, within the nanosecond, picoseconds emitting a neutron will be called as the prompt neutron. Yes, Lakshay is asking another question. How is isotope dilution analysis carried out? So isotope dilution analysis will be discussed around lecture number 31, 32 in that one. So you will get to know more details. Basically, you are determining the specific activity of a particular radioisotope by mixing with the stable isotope. So when you mix the stable isotope, the specific activity changes. Depending upon the amount of the stable isotope that you have added, the specific activity decreases by that factor. So this technique is used to determine the concentration of that stable isotope which you are adding. So this will be made more clear in lectures around 31, 32 and so on. Okay, Sandeep Kumar, sir, in the lecture we never discussed about the role of heavy water. How heavy water is generated and what is its role in the nuclear reactors? Okay, so heavy water is maybe when you are studying nuclear engineering, nuclear reactor engineering, then you will find heavy water will be one of the important nuclear materials. So heavy water is produced by proton will capture a neutron and become deuteron. So the water containing heavy deuteron is called heavy water. The water is produced like there is in the natural water contains 150 parts per million of heavy water. If you have 1 kg, if you have 1 gram of water, then 150 microgram will be heavy water, and then you have to enrich it. So that you can enrich. There are plants which will produce hundreds of tons of heavy water from the natural water. And you can also produce deuterium from neutron capture by hydrogen. So, but there is enough heavy present in the nature in natural water, from which it is enriched and used for nuclear reactor as a moderator. So it is used as a moderator in nuclear reactor because the light water also can be used in the reactor as a moderator, but the light water is made of H2O, the heavy water is made of D2O. And H2O, hydrogen has got higher neutron absorption cross section. So some of the neutrons are captured by hydrogen, and so the neutron economy is affected. Whereas heavy water, deuterium has got less cross section for neutron capture, and therefore the neutron loss is much less when you have heavy water. So heavy water is used as a moderator when the reactor is fueled by the natural uranium. Because you don't have much of fissile material to use heavy water. In light water reactor, when you have enriched fuel, enriched uranium to 35 as a fuel, then you can afford to lose some neutrons, and there light water is okay. So that's how the choice of either enriched heavy water or enriched to 35 uranium is decided based on the type of fuel you have, and then accordingly you decide whether to use light water or heavy water. The idea is to have higher neutron economy for the reactor.
Hello, sir.
Yeah,
Sir, it's 5 am, so should we close the session now?
yeah. There is one question just
Okay,
now.
okay.
So there is a question from Sandeep, sir. In CSIR net exam, the syllabus they have mentioned neutron activation analysis. So how the NAA mode method works. So NAA I'll be discussing in more details in the later part of my course. But in brief, I can tell you that when you put a material in the reactor, then the target isotopes capture neutrons and will become radioactive. And by counting the radioactivity of these isotopes, you can determine what is the concentration of that particular element. For example, if you have cobalt in the reactor, if you put cobalt ore, and you put it in the reactor, cobalt will become radioactive. You count the activity of cobalt 60, you can find out what was the amount of total cobalt in the sample. That is, the NAA is used in determining the concentration of the different elements in a sample by radiating in the reactor and counting the radioactivity. In nutshell, this is the methodology. But the more details you will know when you attend the full lectures. Then Bhanupriya is asking neutron flux higher in 10 MeV or 20 MeV. It is, I am not very clear about your question. Neutron flux higher in 10 MeV or 20 MeV. So you have, suppose you have a reactor, you have the neutron energy range from close to milli electron volt to millions of electron volts. So the average energy of the neutrons in the thermal reactor is 0.025 electron volt. And as you go to higher and higher energy, the neutron will decrease. So neutron flux in the reactor, 20 MeV neutrons will have lower flux than the 10 MeV neutron. If I understand correctly what you mean by this question, that higher energy neutrons will have lower flux than lower energy. And the average, the maximum, the average is 0.025. Average will be slightly on the higher side, slightly on the lower side. You have the Maxwell-Boltzmann distribution of neutrons. So you can write in your discussion forum and tell team if there are any further questions. Over to you, Devendra.
Yes, I can stop now, sir.
Yeah. Okay.
Shall I start now, sir?
Yeah, you can stop.
Okay.